Hello students, in this video we will solve the second problem of the chapter Gravitation from Concepts of Physics by H.C. Verma. According to the problem, four particles of masses m, 2m, 3m and 4m are placed at the four corners of a square of edge A. We have to find the gravitational force acting on a particle of mass m placed at the center of the square. So first of all, let us consider a square ABCD. Center of a square is the intersecting point of the two diagonals of that square. According to the figure, the two diagonals are AC and BD. So if we mark the intersecting point of AC and BD as O, then O will be the center of the square ABCD. Let the masses m, 2m, 3m and 4m are placed at the four corners A, B, C and D respectively. Now the fifth particle of mass m is placed at the center O. We have to find the total gravitational force on this mass m placed at O. So let us solve this problem. According to the problem, length of each side of the square is equal to small a, so we can write AB is equal to BC is equal to CD is equal to DA, and all of them are equal to small a. Let us now find what will be the length of the two diagonals. Since it is a square, length of the two diagonals are same, so the length of AC and the length of BD are same, which is according to the geometry root 2 times A. Now to find the gravitational force on M placed at O, first of all we need to find the distance of the center O from the four corners of the square. Since it is a square, so the point O, that is the center of the square, will be equidistant from all the four corners of the square. Therefore, we can say the distance OA is equal to distance OB is equal to distance OC is equal to distance OD, and all of them will be equal to half the length of any of the two diagonals. So it will be root 2 times A divided by 2, that is equal to A by root 2. Let us now find what is the force exerted by the mass m at OA on the mass m placed at O. To express this force, we will use this type of a notation, F suffix OA. So F suffix OA represents the gravitational force exerted on mass m at O by mass m at A. This will be equal to, according to Newton's universal gravitational law, we have G, product of the two masses, divided by distances square. So if we substitute the value of OA, which is small a by root 2, we will get FOA is equal to 2gm square divided by small a square. Since gravitational force is attractive in nature, so the direction of the force will be from O to A. Similarly, let us calculate the force exerted by the mass 2m at B on the mass m at O. So it will be FOB is equal to again G into product of the two masses, that is m into 2m divided by distances square OB square. OB is equal to small a by root 2. So if we substitute, we will get small gm square divided by small a square. Again, the force is attractive in nature, so the direction of the force will be from O to B. Now the third corner. At the third corner, that is corner C, the mass is 3m. So FOC will represent force exerted by mass 3m on the mass m at the center. So it will again be g m into 3m, product of the two masses, divided by distance square OC square. OC is equal to a by root 2. Substituting the values, we get 6gm square divided by a square. The direction of the force will be from O to C. Now the fourth corner, that is corner D. So FOD will be the force exerted by the mass 4m on the mass m at O. So it will be again G, the product of the two masses, divided by distance square. OD is again small a by root 2. So substituting the value, we get FOD is equal to 8gm square divided by a square, and the direction of this force is from O to D. Now look at the figure. Along the diagonal AC, we have two forces FOA and FOC, which are oppositely directed, are having different magnitudes. So we can say along the diagonal AC, we have two forces FOA and FOC, which are oppositely directed, and the magnitude of FOC is greater than the magnitude of FOA. Similarly, along the diagonal BD, we have the other two forces FOB and FOD, are again oppositely directed, having different magnitudes. So we can write for the diagonal BD, we have two oppositely directed forces where the magnitude of the force FOD is greater than the magnitude of the force FOB. Here, in the next steps, we will be finding the net force along the diagonal AC and the net force along the diagonal BD. So let us first of all find the net force along the diagonal AC. Let the net force along the diagonal AC is F1. Now since FOA and FOC are two oppositely directed forces, hence it will simply be the subtraction of the two forces. Since FOC is greater than FOA, so F1 will be simply FOC minus FOA. Now if we substitute the value, FOC was 6gm square divided by small a square, minus FOA was 2gm square divided by small a square. So simplifying, we get F1 is equal to 4gm square divided by a square. Now since FOC is greater than FOA, so the direction of F1 will be along the direction of FOC. So F1 will be directed from A to C. So F1 will be directed from A to C. So this is the direction of the force F1 along the diagonal AC. Now we will consider the diagonal BD. For the diagonal BD, again we have two oppositely directed forces along the same line. So let the net force along the diagonal BD as F2. So F2 will again be the subtraction of the two forces. So it will be FOD minus FOB. Now what was FOD? FOD was 8gm square divided by a square. And what was FOB? FOB was 4gm square divided by a square. So if we simplify, we get F2 is equal to 4gm square divided by a square. Now since FOD is greater than FOB, so the direction of F2 will be in the direction of FOD. So F2 will be directed from B to D. So the direction of FOD is from B to D. So now we have two forces, F1 and F2. See, the magnitude of F1 and F2 are same, but they are along two different lines AC and BD, where AC and BD are mutually perpendicular, because diagonals of any square are always mutually perpendicular. So from the figure we can write force F1 and force F2, they are mutually perpendicular. So if we can calculate the resultant of F1 and F2, that resultant will give us the total gravitational force on the mass m at the center of the square. So let us now find out what will be the resultant of these two forces. Now we have the situation where F1 and F2 are mutually perpendicular. So therefore net force on M at O will be the resultant of F1 and F2. Let the net force is F. So F will be equal to root over of F1 square plus F2 square, because the two forces are mutually perpendicular. Now substitute the value of F1 and F2. What was the value of F1 and F2? Both of them are equal in magnitude. The value of F1 was 4g m square by a square. The value of F2 is also 4g m square by a square. So substitute the values of F1 and F2. So it will be 4g m square by a square whole square plus again 4g m square by a square whole square, both under the square root. So if we simplify, then the magnitude of the resultant of F1 and F2 will be equal to 4 root 2 g m square divided by a square. This is the resultant of F1 and F2, which is also the total gravitational force acting on the mass m placed at O. Now we have the magnitude of the force. Finally, the direction of the force. So what we have, F1 is directed along AC from A to C. F2 is directed along BD from B to D. Now what will be the direction of F? Remember, the magnitude of F1 and F2 is same. So since F1 is equal to F2, whenever the two vectors, if two vectors are having same magnitude, then the resultant of those two vectors will always bisect the internal angle between those two vectors. So here this F will bisect the internal angle between F1 and F2, so the net force will be acting in the upward direction like this. So we can write, since F1 is equal to F2, therefore this net force or the resultant force F will bisect the internal angle between F1 and F2. Now the internal angle between F1 and F2 is 90 degree. So the angle between F and F1 will be 45 degree. Similarly, angle between F and F2 will be 45 degree. So the final answer of this problem will be the gravitational force acting on the particle of mass m placed at the center of the square is having a magnitude 4 root 2 gm square divided by a square, and it is inclined at an angle of 45 degree either with force F1 or with force F2. This is the final answer of the problem.